या हेलो स्टूडेंट्स, वेलकम बैक। सो इसके पहले हमने पढ़ा कुछ बेसिक कॉन्सेप्ट्स। इट वाज एन इंट्रोडक्शन, ज़्यादातर इंट्रोडक्शन ही था। तो आज हम वेक्टर्स में कुछ टर्मिनोलॉजी के ऊपर ध्यान देंगे, कुछ रूल्स के ऊपर, कुछ लॉज के ऊपर विल स्टडी। सो लेट्स, सबसे पहले यू रिमेंबर दिस, राइट? दिस इज़ द वे यू एक्चुअली विजुअलाइज वेक्टर, राइट? दिस इज़ एक्स एक्सिस। You look at any corner of the room और आपको दिखेगा whatever you see, ये x axis, ये x, ये y, ये z. That is what is represented when we draw a 3D figure. I mean whatever in mathematics, this is what you will see the most commonly used figure, x, y, z. This is x axis, y axis and z axis. They are all perpendicular to each other. This is also another form. If I put it like this, then this is x axis, this is y axis, and this is z axis. So this is the whole thing. To visualize, you can also look at the corners. There are 8 corners of the room, 4 at the bottom, 4 at the top, and you can understand that x, y, z axis are, we can graphically measure that, we can visualize is the most thing. So most common terminology is position vector. If there is a point P somewhere and we have origin, the vector denoted by OP arrow is the vector joining vector with P as terminal point and origin as O, initial point. You can say initial point as O. The magnitude is given by, magnitude is just a quantity. It's given by root over of x square plus y square plus z square. Now what is x, y, z here? It is the coordinates with respect to x axis, y axis and z axis. This is one term, this is one way of writing this. Any vector can be written as, OP vector can be written as x I cap plus y j cap plus z k cap. This you must be knowing. Apart from that, this is the scalar quantity, this is just a number. Just remember this. When I say mod, this is just a number, a value, whatever. No directions. Just like 4, 5, 6, 8, 9, anything. Just a number, no directions. But when we say OP vector like this is a vector and it cannot be a simple value. There has to be some, there has to be a x component, y component and k component. Any of them can be 0 too, that's not a deal. So this you cannot write. You cannot write something like this. OP equals to, when you write, you have to write it in the vector form like this, where this is the coordinates of the point, and that is the line joining the center to the coordinate is x, y, z. So visualize, we have a point here and we join that point with this one. This is the point, okay? This is x axis, y axis, z axis. This is the point and the coordinates. X axis is, how will you determine the coordinate? On the yz, if you want to determine the x component, what you do, you drop a perpendicular on the x axis, right? From here you drop this on the xz plane. On the xz plane, this length is, this is x. If you know, you want to know how much is y, so in this direction how much is, so you drop a perpendicular on the plane x, y, z, here you drop on xz. For knowing x, you drop on, for knowing x, drop perpendicular on xz plane, right? Then you will come to know x. Here is the point. You drop a straight line perpendicular, and then you measure this component, this component. This is the x component. Okay, and you can also know the from when you drop perpendicular on xz plane, from there you can get x and z both. So if you drop perpendicular on this, you know how much is this, so that is x coordinates. You also know this one, so you also know the z component. This is x component. And if you draw a perpendicular on this plane, on y z plane, this is y, you understand that, right? This is yz plane, this is a yz plane, yz plane. So you drop a perpendicular, and this length is nothing but z, right? And this length is your y, this is your y. So you have to drop two perpendiculars. If you drop a perpendicular on x, y, you will come to know x and y both. So this is the formulation, and this, try to visualize this. Okay, so if you drop a plane on yz plane, you get to know y and z, and that is all. If you drop a perpendicular on xy plane, you come to know x and y. This is one thing. Then we'll move on to direction cosines. Direction cosines, it's very simple. If OP makes alpha, angle alpha with x axis, angle beta. Why am using? Because the book is using this. Everywhere people are using this. And gamma with z axis. Then in that case, if you drop a perpendicular on x axis, this is easy to visualize. So this is alpha, so cos x, this is x, and this is the hypotenuse. So this is this hypotenuse. OP, say OP mod OP is r. Okay, so cos alpha equals to x by r. R is a vector actually, but cos alpha is r. Cos alpha is just a scalar quantity, which is this, which is x by r. Similarly, cos beta, you will have difficulty in visualizing because we cannot draw a 3D figure, right? So this is the way people try to, this is perpendicular, this is perpendicular, they don't look perpendicular, but this is the way. Cos beta is cos alpha is how much? X by r. This is y by r. Cos beta equal to z by r. Now you always know OP is also is root x square plus y square plus z square, right? I told you position vector. So you can write it like this also. OP and R are same. OP is OP vector. I am denoting OP by a simple this, and mod OP by this is OP, and mod OP is the value of the length of OP, that is R. No signs. So you know cos square alpha plus cos square beta plus cos square gamma is equal to this square plus this square plus this square, which is x square plus y square plus z square by r square. X square y square z square is nothing but mod r, so mod r is nothing but r, just a value r square 1. So this is the formula which we wanted to evaluate. Sometimes they denote cos alpha by L, cos beta by M, cos gamma by N. So L square plus M square plus N square is equal to 1, L square plus M square. And what is this cos alpha and cos beta and cos gamma? They are known as the direction cosines. So the cosines are known as, the definition says the cosines are called direction cosines, and the sum of the squares of the direction cosines is always 1. This is what mathematics says. Another topic which I wanted to cover is summation of two vectors. Is it fine? I hope I am clear so far. If you still have questions, you can always comment on the comments box. I will be happy to answer those. I can speak in English, I can speak in Hindi. So sum of two vectors. So say x, y, z. So we have a point called B, we have a point called A, two vectors. Now A, B. So AB, this is not summation actually, this is not summation. So this is A, B. First of all, try to know triangle law. Triangle law, what does triangle law says? That AB plus BC equal to AC, which means if there is a triangle ABC, A if here, B here, so AB vector is this vector, BC is this vector, so AC will be the sum of these two vectors. In other words, I told you earlier that if you apply force on there are two forces, one is AB and there is on a single point, on a single object, and there is another force like this. So the resultant would go like this. The resultant, two forces acting on the body. Magnitude will also decide how much it's going in this direction. The magnitude of this is going to decide how much it's going in this direction. If they are equal, this will go in a middle path. So that is why AB denoted by this, BC denoted by this. See, I am trying to align this with this line. If forces apply, say they are applied on an object like this, the body will move in this direction in 3D. So this is triangle law, AB plus BC equal to AC, and just remember AC, negative of AC is CA. So I can also write, if this is O, this is AB vector, right? So this is your AB vector. Similarly, if you have a point somewhere C, this is AC vector. So you have to complete this triangle ABC. So A is OA, this is OB, this is OC. This is with respect to position vectors with respect to origin. But when I say AB, AB is the line joining A and B, the vector joining A and B. This has become a khichdi, but try to understand that if there is a point A and there is a point B, there are two vectors, right? This is position vector of A, this is position vector of B, but AB vector is this vector. Try to understand this, the line joining A and B. So I could have made actually like this. If I want to say this is the vector AB, so if this is A, then this is B, which is this, and there is a C point somewhere here. 3D, this is not 2D, please remember that. C, and there is a BC. So AB plus BC equal to AC. So I messed up a little. This is C, this is A, this is position vector OC, OA, OB. I draw, this is OA, this is OA, this is OB, this is OC, and the vectors add up like this. So in any time you just complete a triangle like this, you want to add these two vectors, try to bring it parallel so that it's aligned here, and then join this point. This is the resultant of this. This is the whole formula. Again I am trying to explain. These two vectors you want to join. You should not move it here. You move the starting point, initial point of this one, move it parallel and bring it here. This is AB, this is BC, and the vector will be from not from C to A but from A to C. So AB vector plus BC vector equal to AC vector. Remember this. This is triangle law. So let me see if another thing I wanted to say, a vector, if you multiply a vector, say AB, you multiply by it by a magnitude say m. जैसे कि फोर्स को बोल रहा हूँ दुगना फोर्स लगाया, I say I applied twice the force, which means force is a vector, twice the force is the vector, so the magnitude gets multiplied and the vector becomes MAB. So magnitude of M, let me write like this, no. A vector AB, okay, if you multiply a scalar by this vector, if I say 2 गुना force लगाया, which is nothing but 2 into the magnitude of this one will be twice. The magnitude gets multiplied by the scalar. If I say 3 times I applied the force, which means 3 times in the same direction, so it becomes, you can simply multiply. Additive inverse, nothing, AB, and there is a vector BA just opposite to it, BA, or say PQ, or you say BC, okay. If you align AB, you write like this and you bring this one here, so there a triangle is not completed, but say imagine a triangle is completed, so the triangle's sum is also A, I mean the starting point is also A and the ending point is also A, so it's 0. So AB plus negative of AB, I should write like this, equal to 0. or you can write like this also, a vector plus negative of this vector equal to 0. Acha. Another thing, we talked about iJk. iJk is our unit vectors in directions x, y, z. See, always remember, iJk you don't use always. These are unit vectors in directions of x axis, y axis and z axis. But there can be a vector, and if you want its direction, so if unit, the way you apply unit, meters, centimeters, so many meters, so many units. So if there is a vector, say AB, with magnitude like this, say r, and you can write AB as r into another vector, say k, let me say by what do I select, say p, sorry, I should have, so p, this is r, sorry, r, and this is r, and p is the unit vector in the direction of AB. That is a unit vector. Unit vector you can simply understand like this. Say this is 5 newtons in direction, whatever direction. So 1 Newton is a unit vector in that direction. It should be 1/5. It looks 1/5, right? Unit vector in that direction into 5. The magnitude is 5 newtons in that direction. I hope you enjoyed the class. You understood the class. We'll cover more. You know this, right? The I, J, K, they are all 1. So I hope I was able to make myself clear. Addition of vectors, if you want, you also, if there is a vector, say A with x I cap plus y j cap plus k cap, and there is a vector B which we said AB and BC, just imagine like this. So this is P I cap plus Q j cap plus R k cap. You can add the resultant vector AB plus BC, which means AC, as we read, as you can simply add the magnitudes in the direction x, y, P, Q, R, K cap, Z plus R, K cap. You can add these vectors. So I believe this much should be sufficient for today. We'll study more. We'll study, what do we study next? In the next class we'll study scalar product and vector product, dot product, which is scalar product, and cross product, which is also known as vector product. We'll study that in the next class. I hope we'll resolve a couple of problems maybe in the next class first, and then we'll cover scalar and vector products. Thank you so much for watching, and please do subscribe my channel if you liked the video, and hope you have a nice you had fun, right? So let me know in the comments box. Thank you so much for watching.